This is Justin Tang's submission for Homework 7 Question 2. Here I am showing the organization of my files. As you can see, I've created folders just to include the raw photographs from the Raspberry Pi. I have 4 for the 4 different angles of attack. Here you can see that the images are much improved when using the long exposure script. As you can see, the red line laser shows up very nicely, but there are still reflections from the metal and the glass sides of the building, which are not going to be able to be filtered out by the HSV mask. I also created folders where I copied all of the photographs into the folder and also included the color picker script. As you can see, I have 4 scripts individually for the 4 different angles of attack to generate the data. The data is recorded in 4 different text files for the 4 different angles of attack. Here I am utilizing essentially the exact same data generation script. Here I am still inputting the HSV values that are gathered from color picker. Although I did try the color booster script, I ultimately made only one change, and that was to handle an issue with the angle offset algorithm. This angle offset works fine for angles above 0 degrees or above horizontal. However, for angles between about 320 and 340 degrees, the algorithm would give me a negative range value for y and z. Therefore, I included a for loop, or actually just an if statement, such that only angles that are less than 300 degrees were handled by the angle offset algorithm, and other angles were neglected. This here is where the algorithm seems to cause issues when we try to apply a sine and cosine to certain angles, which result in negative values. As you can see here in the Matlab script, we are calling all 4 text files. Here we are extracting the data. As you can see, the front angle of attack is still being used as the datum. Here I am doing different operations, very rudimentary, where I'm just flipping the data set, flipping the x values and y values, and adding just offset constants in order for all 4 angles of attack to be quote-unquote stitched together. In the future, I plan to use a much more sturdy algorithm, and I plan to accommodate. I ultimately found that the best way to stitch the data together was to plot all 4 angles of attack separately. By doing this, I could adjust the colors for those angles of attack that I felt were properly oriented to all the same color, and then introduce a new angle of attack with a different color. This made it easy to visualize the changes that I needed to make and the different constants that I needed to add. Here you can see is the script that I ultimately used, which was one 3D point cloud produced by a vertical concatenation of all the different x, y, and z values. If we run the code, we will find a single point cloud being generated that includes all 4 angles of attack. Here we can see this 3D point cloud. You can definitely make out the bust and also the platform. The bust is actually fairly well defined in terms of the shoulders, torso, chest, and head. You can see that the bust is clearly leaning forward, and if you look closely, you can even see the arms being interlocked behind the body. Also, if you look closely enough, you can see the buttocks of the bust. You can also see that the platform, or the podium, is a little bit imperfect. The sides of the platform are inclined, which is exactly what I expected because I could not apply the angle offset algorithm to these points. As mentioned earlier, these originally would cause negative values. As you can see, there is still some noise in the data, and this is likely due to the reflections captured at certain angles because of the glass building. Overall, I think this is a very good first 3D combined cloud, but there's a lot of post-processing that can be done.